Okay, friends, we are going to take a look at our second lesson in Max-Min, and today we got a couple problems to look at. So let's take a look right now. So there are three problems we're going to look at. We're going to look at the cereal box challenge, which you are all vying to win great cereal box prizes. So the solution to that will come out after the prizes are given out. I'm going to focus on this problem right here. Find the points on the parabola y equals 6 minus x squared that are closest to the point 0.03, and this business revenue question. And so let's look at these two problems. Okay, so let's go. So first things first, let's make sure we understand the problem. So click on the graph to show the top blue dot. So basically we're trying to figure out how can we get that blue dot as close as possible to the other blue dot. In other words, make this line the shortest. So let's take a look at it. I encourage you to click on all the Desmos links in our slide. So basically what we're trying to do is find out when that line's shortest. And to me, it looks like somewhere around there or somewhere over there. So I'm expecting to have two answers here. So that's what we're doing. Now, just to give a real big hint on this, let's make it look like a triangle because we know that slope is based on an x and a y. And as soon as we do that, I sure hope you're starting to think about what formulas or equations we might use to find the solution here. So I want you to pause the video and think about which equations you might use here. Okay, I trust you pause the video, and I hope that you were saying something like Pythagoras. Maybe we want to think about slope here, maybe not, but definitely Pythagoras. And I hope you're also thinking about that original equation. So without further ado, let's get into it. Okay, so first things first, I hope that you can see that this is essentially a right triangle, and it has three sides. And we can label those three sides. Let's call that D. I'm going to call that D for distance, and so we know that D squared equals A squared plus B squared. We know that. And what we're trying to do is figure out what A and B values make the D the absolute shortest. So that's what we're going to try to do. And in doing that, we're going to get a sense of what the x values are. So I think it's safe to say that we could call this coordinate here 0, 3, and this coordinate right here is the coordinate x, comma, 6 minus x squared. That's how you find the y values. You put an x value in for the x in x squared. So we're going to basically fill it out, and we know that a is basically going to be the distance between x, and let me get my pen out. So here's x right here, and here's 0 right here. So the gap between those two is simply going to be x minus 0. That's that horizontal piece. That's how long it is. Okay. Then what we're going to look at is the vertical, and the vertical is simply going to be this vertical height minus this vertical height. So we're going to have the 6 minus x squared, which is the top, subtract the 3. So that's this vertical height right there, okay? Okay, so now what we're going to do is we already labeled that A and B, and we're just going to substitute. So there we go. I've placed the x minus 0 in there, and that's just another name for A and B. We're going to square both of those, so that's squared. We're going to simplify, go 6 minus 3, and we're going to square that. We're also, what I did, and you don't have to, but you could, is I'm just going to expand that all out and clean it up. In other words, simplify, because we know we're going to need to take the derivative eventually. So D is going to equal the square root of that polynomial there. Alrighty, so let's keep on going. This is a pretty gross derivative. Remember, I missed a line here. Oops. So this guy right here, did I do that? I did not do that. Okay, so I'm going to do it by hand. So we know that this would be the same as this to the power of 1/2. And the chain rule is still with us. We're going to be using it a ton. So we know that the half comes down, check. It's the same function there, and then the half minus the 1 gives us this, and then we need to multiply all of that by the derivative of the piece inside. So that's the chain rule that I just used. Okay, you'll see in this next line here, this could be trouble for some of us. Notice that this guy right here, because of that negative exponent right there, is going to put that whole thing on the bottom, which is where it's going to go. The one is naturally on the numerator, and the 2 is part of the denominator because it's in the denominator, and this piece here just goes on top. So hopefully you can understand how we rearrange that. We've done that a ton of times in various sections. So now what we're going to do is we're going to set it equal to 0, because remember what we're trying to do is take a look at where the slope or derivative is 0. I might pause. Yeah, no, I won't. I'm going to look at Desmos soon just to show you what the graph looks like. As we cross multiply, this is really cool. Check this out. When we cross multiply this term by 0, that's just awesome, because when we do that, that's just going to go to 0. I'm going to come back and make a point later that's going to be really even cooler than this. Okay, so then what we're going to do is we're going to just factor that thing, which I've done, 2x and 2x squared minus 5. And obviously one of the critical numbers would be 0, which doesn't make a ton of sense here if you think about it. And the other ones are going to be, the square root of this value, which was taken by going 2x squared minus 5. Take the minus 5 to the other side, so that would make it equal to 5. And then we're going to divide by 2 and square root it, and that's where you get both of these values. Okay, so that's the solution right there. Those are the closest. That's the closest x value, and then we can sub that back into the equation to find y. A couple observations I'd like for you to notice, and it's right here. I'm not sure if this makes sense to you, but if we find values that make d the smallest, then if we square all these things, if we square all these things, that would mean that d squared would also be the smallest. So this might be a bit tricky for you to grasp, and you don't have to do this, but check this out. Notice how here, basically what happened was this basically canceled out, because when it multiplied up. What some of us will know is if we look at this guy right here, d squared equals that. If we minimize d squared, in other words, take the derivative of d squared, and I don't mean like 2d, I mean think about d squared as though it's a variable, like just let's call it a. So if we take the derivative there, look at this. This is going to be 4x cubed minus 10x. And look at that. So we could potentially skip all that if you understood what I just said. So if d is a minimum, then if we square it, it also too will be a minimum. So that's all I did there, is I just saw d squared as a single variable, and it's just like the derivative of d squared is just d squared prime. That could confuse some of you, so don't go down that path if you don't know what I'm saying there. But do notice that those two are the same. Okay, so be careful there. Here's another observation. If this just said find the shortest distance, here's what a lot of us are probably going to do. We're going to take that equation right there. We're going to scoot over to Desmos, and oh, there's nothing here. Whoa, I'm surprised by that. So I'm gonna put that equation in there. So I'm gonna go x. I'm gonna put x squared in there. So x squared. Was it plus? I can't even remember. Plus. Okay. Then we went the square root of x squared minus 3, and all of that was. Oops, oh, that's getting kind of crazy. Okay, we're going to do that. And what else do we need to do here? We're also going to, you know what, I'm going to square root that, because I'm going to go, sorry, I chose the wrong piece there. I'm going to put all this under square root sign and put it right there. And we are going to zoom out. I've made a mistake here somewhere. Or is that a minus? What have I done? Oh, because I put x there. That's supposed to be a 3. That looks a heck of a lot better to me. Do you notice right here that they're the two smallest values, and those correspond to these values right here, I believe. Oh boy, just one sec. Okay, yeah, friends, I just made a little mistake here. This was 3 minus x squared. I'd had it x squared minus 3. And you'll notice here, that's the x value at which the minimum happens. That here in this graph here represents the shortest distance. That's the shortest distance. That's not the y value on the function. So we should just be clear about, so that's the square root of 2.5, and that's the shortest distance that's possible there. So as we come back, we found this part, and to find that guy, of course, you put that back into the original equation. So there you go. Obviously a tricky question, and I hope that helped you out. All right, let's look at one more challenge. Okay, so this guy here says a business has conducted an analysis of pricing for their product and created the following revenue model. Okay, what do those variables mean? P, where n is the price of the item and R is the total revenue. So I'm going to take a guess that this should have said N and N and N there. So that's a mistake in the question. So I'm going to call this N is the price. I have no idea why I'm probably going to change that in the thing before you see this, is that's going to be a P, not an N, and this is the revenue. Okay, this to me looks like it has a y-intercept at negative 11,000. Okay, and it's a parabola that opens down, so it's going to look something like that. And it's a parabola, so we're basically trying to find that maximum height. And so that's going to be pretty straightforward for most of us, okay? So here it is, we're going to take the derivative. So the derivative of negative 100 is p squared is that. Here we go, and then we're going to set the derivative equal to 0 and solve. And so p equals 40. And they say check our answer in Desmo, so I'll play that game. And so what did we get for a value? We got p is 40. So p is 40, and I put 40 back into the original equation. I'm going to graph that. That graph is given for us. The best price is right up there at 40, 149,000, So I didn't take the time to find that coordinate, but we'd simply find that coordinate by putting 40 back into the original equation. So as you can see, that's a pretty quick one. And really, at this stage, you really should have your digital portfolio be full of all the evidence of the many strengths that you have acquired so far in the course. So I hope that you're going to do that. You should be adding 2 to 3 statements per week. And I know for some of you, you're going to want to get on that. Best of luck, and we'll see you soon.